Hey guys, welcome back. In this particular video, we're going to be taking a look at OSPF on the ASA firewall. And again, just like EIGRP and RIP, there are a lot of similarities between running OSPF on the ASA and the router, but there also are some differences. We'll take a look at them as we go through this particular video. The main topics, just like the other routing protocols on the ASA, configure OSPF. How do you do it on the ASA firewall, and how is it different from a Cisco router, the configuration commands associated with it, OSPF authentication, configuration of the OSPF authentication, the commands, verification commands, and at the end, we'll do the lab. So again, configuring OSPF, just like the router, the command is still the same. The router command enables OSPF, the process ID followed by the OSPF command. The process ID is locally significant, can be any number, just like the router, nothing different over here. Again, if you want to set the router ID, same command over here, router ID dash 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 or x dot x dot x dot x. You do need to put it into an area just like you do on a router, nothing different over here. And the way you do it, the router into a particular area is you configure the network statement and put it into the appropriate area over here. So for example, on a router, I would have done 000255 followed by the area command that you want to put into. Here, we don't really want to get into the multi-area concept, so we're just going to do the normal single area with area 0. On the ASA firewall, the same command, just like we talked about in EIGRP, ASA does not have a wildcard mask, it has the normal mask, so it would be 10.1.1.0 255.255.255.0 area 0. Very similar with subtle differences that you need to be aware of. So this is how you initially configure OSPF. Then again, the network statement, same concept, same everything. The only thing that I need to do over here is change the mask. The mask over here would be 255.0.0.0, and it is a requirement that you put the mask in. It's not like EIGRP where you leave the mask off, it takes the default mask. You do need to specify the mask over here, just like that. So again, on the ASA firewall, enable OSPF by running the router command, followed by OSPF. Set the router ID if you want to. If you don't, you'll pick the router ID based on the highest IP address on any of the interfaces that you have on the firewall. The network statement, the only difference is the mask. The mask is a normal mask, whereas on a router, the mask is the inverse mask. So that's what this is over here. This is your basic config. As you guys can see, it's almost the same as a router, except for the mask is the normal mask. In terms of authentication, this is one protocol that is very similar on the ASA firewall and on the router. Authentication with OSPF, just like as a normal standard for OSPF, supports text as well as MD5 authentication. Both are supported on the ASA firewall as well. Clear text, not the preferred one, MD5 the preferred one. Now the way you do that on the ASA firewall versus the the router is almost the same. You don't have the concept of a keychain even on the router. When you're doing authentication based on OSPF on the router, you do it under the interface, exactly the same way that you have been doing it for the other protocols. For OSPF, RIP, EIGRP, we did not have a keychain concept. We put the authentication method and the key under the interface. Even on the router, if you guys remember, on the router, it is the same. The authentication mode and the key configuration is done directly under the interface on the router as well. So it's no different over here. You do have the ability to specify the authentication mode under the routing process, but the key needs to be specified under the interface. Again, applicable to both the router and the firewall. No different. Let me give you some examples of that so you guys have that. Two different ways of doing it. I could either go under the interface and specify my authentication mechanism. For clear text IP OSPF authentication, that turns on clear text authentication. IP OSPF authentication dash key and the password, this is your key. For clear text, this is how you do it under the interface. Now on the ASA, I do almost the same thing. The only difference is I don't put IP in front. So OSPF authentication is clear text. OSPF authentication dash key, Cisco 123 set the way you set the key. Now, the other thing that I told you about was you could potentially go ahead and enable the authentication on the area, under the routing process. What that basically means, and this is very critical to understand, when I say area 0 authentication, does not mean all routers in area 0 need to be authenticated based on OSPF. All this means is all interfaces on my router belonging to area 0 should have clear text authentication. How does it help? Let's say I had 4 interfaces on my device, all in the same area, area 0. So rather than doing 2 commands, these 2 commands over here, 2 commands over here, 2 commands over here, 2 commands over here, in which one of the commands is common, which is basically specifying the authentication method. So what I could technically have done is under the OSPF process, I could have put the command saying all interfaces belonging to area 0 should be authenticated based on clear text, and then instead of doing 2 commands under each one of those interfaces, I would just do 1. And what is that 1? That is a key. Key always needs to be specified under the interface. So that's the advantage of doing it based on this. And this is available to you both on the ASA as well as on the router. So if I had to do the same thing on the router, I would have done router OSPF 1 area 0 authentication. That sets it up for clear text, all my interfaces for clear text, and then under the interface, all I had to do then was just one command. That was the key command, IP OSPF authentication dash key Cisco 123. So I did not need to do 2 commands on the router. I would do 1 command under the interface. Helps if you have a bunch of different interfaces belonging to the same area that want to do the same type of authentication. This is clear text though. This I showed you how to do clear text on the router and then on the ASA using the all interface mode or the authentication type under the router mode and the key under the interface. Either one is fine. As you guys can see, it's very similar to the way the routers and the ASA firewalls do authentication, which is different than RIP and EIGRP, which require a keychain for the router process. So for MD5, same concept. The command though for setting up authentication is IP OSPF authentication. This was the same command for text, but I complemented with the message digest, making it MD5. And the way you set the key, IP OSPF message digest key 1, key ID, MD5 is a keyword, MD5 Cisco 123. Again, if I want to do it globally, router OSPF 1, area 0 authentication, message digest, and then under the interface, just a key. For ASA, almost the same. Lose the IP command in front, the rest of it is the same. Now, if I had to do the same thing globally under the routing process, I would do router OSPF 1. This is on the ASA because I showed you the example on the router for the global. I didn't do it for the ASA. This is the way I would do it on the ASA. If I wanted to do this, area 0 authentication, message digest. So I set up the authentication globally under the routing process, and then under the interface, I would only need to do what? The key command, which would be the OSPF, message dash digest dash key 1 MD5, whatever. You guys understand that? All right, so both ways of authentication that you can do on the router as well as on the ASA is explained over here, guys. So you should be good with that. Now, verification commands, I need to fix this again. Show IP router. displays a running config for a routing protocol. So it'll show you the entire running config for that routing protocol. Show route shows you the routing table. Ping to verify it. Now, with that in mind, let's do the lab. Again, we were running EIGRP before this. We'll get rid of EIGRP on the ASA. We have that command clear configure router, which will get rid of EIGRP over here, and on the routers, the normal no router EIGRP command. So that way, we're reset with just the IP addresses on the interfaces, no routing. Let's do that first. So I'll first do it on the ASA. Clear configure router. This should get rid of any routing protocol I'm running. Show route. It should just have directly connecteds right now. Let's go to router 1 now. No router EIGRP 100. And I'll do the same thing on the other routers as well. Gone, gone, and gone. All right. So this part is done. Now let's go ahead and take a look at your OSPF configuration. What's the lab wanting you to do? Clear the config. We've done that for EIGRP. Run OSPF and process ID 1 on all routers. You don't need to match them. They could be different. The lab's just asking you to do it the same way. Make sure the 10.0.0 networks are reachable from the ASA. Use area 0 for all networks. We'll do clear text authentication between, the ASA and R3. We'll do that later. Let's get the OSPF up and running first. So router 1, router OSPF 1. Let's set the router ID as 1111, although I don't need to. 10.0.0.0. Any interface that belongs to 10 should be enabled in area 0. That should take care of all my routes because all my routes on router 1 are belonging to the 10 network. And on the ASA, router, because I want to demonstrate the mask over here, I'll say router ID is 10.10.10.10. The mask over here, 10.11.11.0, is the normal mask, not the inverse mask, area 0. Now, it'll take some time for it to come up because OSPF goes through that 40-second wait period, although you should now see there, there should be a neighbor relationship that is started. It does wait for about 40 seconds to come up. In the meantime, what I'll do is I'll configure my other routers, which is router 3 and router 4 for OSPF. So how do I go about doing that? While I'm at it, on my ASA 3.0.0.0.0.255 area 0. Oh, I'm on the ASA, so it should be what? 255.255.255.0 area 0. And then I'll do the 4 network as well. I'm doing the DMZ routers right now. So router OSPF 1, router ID, let's say 3333, network 68.3.0, the inverse mask, and network 10.3.3.0, the inverse mask. It's a router. Router 4, router OSPF 1, router ID 4444, network 4.0, inverse mask because it's a router. This should set it up. Let's check if any of the neighbors have come up. Show OSPF neighbor. Guess what? One of the neighbors is up. The other ones are about to come up. They're in the Xstart state and eventually they'll go to full. So if you check your routing table right now for OSPF, I've got 10.1, I got 10.3, 10.10, and 10.20 from the inside, and the DMZ3 is up. Give it some time, and 4 should also pop in. Come on. There you go, full. Show OSPF, show route OSPF, and this guy is up as well. Now let's do the outside network, which is 20.0, also in area 0. By the way, the ASA supports all the multi-area configurations that you would do on a normal router as well. So my outside interface is configured as 20.0 in area 0. Router 2, I'm going to do the 10.2 network and the 192.1.20.0 network in OSPF, again using the wildcard mask over here because I'm on a router. Router ID 2222. If you don't specify, it'll pick the highest loopback on a router. 192.20.0, and I am going to use the inverse mask over here. And my 10.2 network, again the inverse mask. Let it come up. Once it comes up, I shall have all my OSPF routes present. Again, it's going to go through that wait period. Let it come up, and once it comes up, we can check the connectivity. It's an X start, so it's moving forward. The connectivity I'll check to is 10.1, 10.2, 10.3, 10.4, and the 10.10 and 10.20 networks once it pops in. Still not there yet. There you go, looks full. And let's check the routes now. Show route OSPF. There you go. All the routes are there. Let's ping it. 10.1 is pingable. 2 is there. 10.3 is there. 10.4 is there. And you'll also have the 10.10 and 10.20 networks. All of them are there. So all the reachability around the routers is done. Now the last thing that we need to do is the authentication bit of it. And the lab requires you to do authentication based on clear text with R3. So let's do clear text with R3. How do I do it? The good thing about over here is that both on the router and the ASA, the authentication is done under the interface. So I'll go under the interface on R3. It's clear text authentication. So the command is IP OSPF authentication, enter. When you say IP OSPF authentication, it means clear text authentication. And now I'm going to set the key as Cisco 123. So within 40 seconds, what's going to happen is my neighbor relationship will come down. Why will it come down? Because the authentication is mismatched. So as you guys can see, the dead time, it's dropping. Normally, this dead time will be between 30 and 40 seconds because after every 10 seconds, I get a hello packet and resets. Because the authentication is not matching, it's going to ignore the hello packet and it eventually gets the timer down to 0. And guess what? My neighbor relationship is down. No neighbor relationship because I haven't configured the authentication on ASA. Where do I do it? On the interface facing R3. So my interface facing R3 is gig02. So over there, I'm going to do authentication. So gig02, I'm there. OSPF authentication, enter. That means clear text authentication. OSPF authentication dash key Cisco 123. Once I do that, my authentication should work and my neighbor relationship should come back up. There you go. Neighbor's up, which was down before. Now it's come back up because the authentication is successful. You can check that on the router by doing show IP OSPF interface E0/0, and you'll notice that simple password authentication is enabled. If I want to do the same command on the ASA, show OSPF interface DMZ3. Simple password authentication is enabled. All right. Now let's do the outside. The outside, the requirement is to do MD5 authentication using a keystring of Cisco 555 with a key ID of 1. Very similar on the two devices. Let's do it on the router first. Under the interface, IP OSPF authentication, but don't stop over here, message digest, because I want to do MD5. And for MD5, the command to set the key is message digest key 1, the key ID, the keyword MD5, and the password, Cisco 555. So now again, show IP OSPF authentication, or no, sorry, authentication neighbor should go down. Notice it's coming down slowly by slowly. but it will come down eventually to 0. It will drop. 4, 3, 2, 1, boom. There you go, it's gone. So no more neighbors over here. Why? I have not done authentication on the ASA firewall. Again, on the ASA firewall, very similar on the outside interface. This is the interface facing the outside router. So I'm doing it per interface. Need to do it per interface on the ASA as well as on the router. So how do I do it? Lose the IP. The rest of the command is the same. OSPF authentication, message digest, OSPF message digest 1, MD5, Cisco 555. Done. Once this is done, my OSPF neighbor relationship should come back up. Show OSPF neighbor. You'll notice 2 is back as a neighbor. And again, if I want to check it, whether the authentication is going on or not, show OSPF interface, and this is the outside interface. Message digest authentication is enabled. And I do have a neighbor up adjacent with neighbor 2222. So you can again check your routes to see all the routing is there. Still there, I can still ping 10.2.2.2. Oops. Or 10.3 because that's another authentication that we implemented. All the commands are here. So initially, I did it on the ASA firewall. I did the entire config. I cleared configure, not route. It should be router over here because I'm getting rid of the routing protocol. Then I enabled OSPF 1. I set the router ID as 10.10.10.10. Enabled it on the 20 network, the 10 network. Let's do it based on the inverse mask so you guys can see it. I didn't need to, although it would have worked. I want to do it like this. 192.168.3.0, 4.0. I've enabled it all the interfaces in area 0. And then I did authentication under gig 00, which is the outside, which is MD5. I did authentication on gig 02 towards the DMZ using clear text. When you say OSPF authentication message digest, that's MD5. If you don't, it's clear text. OSPF message digest 1, MD5, Cisco 555 is the password on the outside, 123 on the gig. Now on the router side, on router 1, I got rid of EIGRP, enabled OSPF instead, enabled it on all the interfaces. On router 2, no router EIGRP 100, enabled it under the OSPF process, enabled the different interfaces, and then enabled MD5 authentication under the interface. Lab configuration on R3, again, got rid of EIGRP, ran OSPF, and did clear text authentication. R4 just got rid of EIGRP, replaced it with OSPF. Verified it by pinging, which was all good, and that concluded our OSPF lab. Now, what we're going to do next is run BGP on your ASA firewall as well. I'm going to use this lab as the foundation. So all my internal networks I'll still use, OSPF for, and BGP I'm going to run with the outside interface. Thanks for joining us. See you guys in the next video.